In the previous video, we had discussed about two things. When we have the same, more than one of the same substituent, and if different substituents are present, how would we name the compound? In this video, we are going to be talking about different substituents at equivalent positions and complex substituents. So when you have different substituents at equivalent positions, how do you give them? How do we number the chain? So let's look at this. Here you have one. Again, we are going from right to left and then left to right. So 3, 4, 5, 6, and 7. And it's going to be 1, 2, 3, 4, 5, 6, and 7. So here you have, first of all, in case of this colored ink, that is from right to left, we have the methyl group at the 5th position and the ethyl group at the 3rd position. Whereas when we number it with the blue ink, the methyl group is present in the 3rd position, whereas the ethyl group is present in the 5th position. So which one would be correct? So the numbering is based on the alphabetical order. So basically the one which first of all, between M and E comes first. So E should have a lesser number. So 3 ethyl and 5 methyl is the right thing compared to 5 ethyl and 3 methyl. So this one is the right numbering and this is wrong. So the name of the compound would be alphabetical order. So 3 ethyl, 5 methyl, and since there are 7 carbon atoms, heptane. So we learned that if there are multiple substituents, their names are put down in the alphabetical order. But if there are equivalent substituents and they are different substituents and they are in the equivalent positions, then the numbering is given based on the fact that the one which is before in the alphabetical order, which means ethyl is given compared to ethyl and methyl, ethyl should have a lesser number than methyl. Assuming we had, let's say there was a propyl group again, then obviously methyl would be given the lesser number than the propyl. So that's what we're talking about. That's what we mean by different substituents at equivalent position. Numbering is given in the alphabetical order. So it's in the order. Next one is complex substituents. Now in this particular chain you have 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Okay, this is one chain. 1, 2, 3, 4, 5, 6, 7, 8. This is another chain. So obviously 10 is greater than 8, because of which this is our main chain. Now this has a complex substituent. If you see, till now we only talked about methyl group or an ethyl group or even a propyl group, but we've never seen such a complex substituent. So this particular substituent is named inside brackets. So it's named within brackets. First of all, this is the substituent in this compound. Okay, now let's number it. So if we go from right to left, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Sorry, left to right. And then from right to left, it's going to be 1, 2, 3, 4, 5, 6. So obviously it's at the 5th position. So we'll be doing it in this order. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So that's our longest chain. So that's a decane. It's easy, right? Now at the 5th position there is this complex substituent which is present and we need to name it. So first of all, the numbering for this complex substituent is given from the carbon that it is attached to. So generally when we number the chains, we pick the longest chain and all of that, but in the substituent we will be considering the carbon which is joined the main chain, that is the longest chain. So this gets number 1, this one is number 2, number 3. Now the first carbon is bound to a methyl group and the second is also bound to a methyl group. So you have two methyl groups at the first and the second position. We call it dimethyl. Now, how many carbons are present in this chain? 1, 2 and 3, which means it's a propane group. But because this is joined to another, another structure or the longest chain, this will be called propyl. Okay, so you have, first of all, we know it's a decane, 10 carbon atoms, and at the fifth position, some complex substituent is present. So let's name this compound. So the complex substituent is present at the fifth position. So 5 bracket. This is done to ensure that we don't get confused between the numbering of the long chain and that of the substituent. So 5, 1, 2 dimethyl, and because this is not the main chain, we will not be writing propane. Instead, we will be writing propyl and decane. So first of all, what we're doing is substituent. If a substituent, first step to having a substituent is you have to identify what is the substituent. So where it is present, which carbon is it attached to. Then what you can do is first number the carbon atoms of the substituent and name it like this. And then you just have to write the position of the carbon to which the substituent is bound to, write the name of the substituent and the long chain. Now let's do another one. So here you have again a long chain. So let's number it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 carbon atoms. If we go downwards, it's obvious that there are just 3, but there are 5 more over here. And so 3, 4, 5, 6, 7, 8, 9 and 10. So you have 10 carbon atoms. Now the substituent is attached to the fifth carbon atom and this is the substituent. Now since again this carbon chain is 10 carbon atoms long, the name of this chain would be decane. Now we need to name this chain. Now as we discussed in the previous example, the numbering is given based on the one is given to the one which is attached to the main carbon chain. So CH2 gets the first number 1. Let me use a different ink so it's easier to understand. So this is 1, then you have 2 over here, then you have 3. If 3 was here or here, irrespective of that, you have 2 methyl groups attached to the second carbon atom. So let's name this substituent. So it has 3 carbon atoms, which means it's a propyl group. So it's a propyl, and because it's a complex substituent, we will not be writing propane, but we are writing propyl. Next, it has 2 methyl groups in the second position. So which means that 2, 2 dimethyl. Because it is again that methyl group is attached to another chain, right? So it is 2, 2 dimethyl propyl. That is the name of the substituent. So the name of this compound will be, first of all, the carbon atom to which the complex group is attached to. So 5, 2, 2 dimethyl propyl. So that's the name of the substituent. And then decane. So that's the name of this compound. The last example. Here you have 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. And then you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think I've written Okay, so you have one, this is 10 carbon atoms long, 1 2 3 4 5 6 7 8 9 10. Now there are two chains which are possible. Now if you take the straight chain, you only have two substituents, this one and this one. But based on the longest chain rule that we studied, if you have two possibilities with the same number of carbon atoms, then we have to consider the one with the maximum number of substituents. So we will be considering this chain because it has 1 2 and 3 substituents. Okay, so here you have, okay, we'll be considering this chain, which means 1 2 3 4 5 6. This basically, this compound compiles all the rules that we've learned from the beginning, 7 8 9 and 10. So here the position 6 has a substituent, position 8 has two substituents, and in case of the opposite direction, let's just number it. So you have 1 2 3 4 5 6 7 8 9 and 10. So according to this, position 3 has two substituents and position 5 has one substituent. So obviously 3 3 5 is considered, where 6 8 8 is not, based on the first rule of difference. Now the complex substituent here, for first of all, the third position, you have two methyl groups, so that's done. So let me just write that somewhere. So you have two methyl, so 3 3 dimethyl. Okay, and we also know that this has 10 carbon atoms, so it's a decane. We need to figure out what the complex substituent's name is going to be. Now because they are numbered from the first one, that is, the one which is attached is going to get number 1. This is going to be 2, 3 and 4. So it has 4 carbon atoms. So the substituent is the butyl. Okay, and at the second position, it has an ethyl group attached to it. So the ethyl group, that is CH2CH3. So it is 2-ethyl butyl. Now this is the name of the substituent. So we got the name of the substituent, which is the complex substituent. We have the name of the our substituents, the normal substituents, and the word root. We need to put this all together, and since butyl, I mean alphabetically speaking, 2-ethyl butyl comes before 3 dimethyl, and so first it's attached to the 5th position. So 5 2-ethyl butyl, okay, 3 dimethyl decane. So here, when we have a complex substituent, the first carbon is the number 1 is given to the carbon atom which is attached to the main chain, and then it is named. To avoid confusion, we place the name of the substituent in a bracket. So this 2-ethyl butyl indicates that there is a 4 carbon chain attached to the 5th carbon atom, and at the second position of that 4 carbon chain you have an ethyl group attached to it. So with that, we finish nomenclature of organic compounds, not too fast, for branched chain alkanes. In the next video, we are going to be talking about compounds that consist of double and triple bonds, or rather they contain double or triple bonds. So do check it out.